153. Find the minimum in rotated sorted array. So in this problem we are given an array of integer. The array was sorted in ascending order and then rotated. So our task is to find the minimum element in the array. So what those mean? Sorted numbers are in increasing order. Sorted means numbers are in increasing order, like 1 2 3 4 5. They are in increasing order. Okay. So the minimum element is 1. What does mean rotated? Some elements from the beginning are moved to the end. Like we have these numbers. If you rotate this number, it's look like this: 4 5 1 2 3. So after rotation, the array is divided into two parts. Okay. So left part is bigger parts, and right part is smaller part. They are divided into two parts. Okay. The minimum element is always in the right part. So the idea is the minimum element is always in the right part. So we don't want this array. Okay. Let's see. In this we have like this: 3 4 5 1 2. So the minimum element is 1. Okay. So if I have like this example: 4 5 6 7 0 1 2. So the minimum element is 0. Okay. If we have no rotation, we have just like in increasing order: 1 2 3 4. So the minimum element is 1. Okay. So the idea, the array is sorted but rotated. Okay. Rotation creates two sorted parts. After rotation, they are create two sorted part. This is also sorted now, 4 5, and this is also sorted, 1 2 3. The minimum element is the start of the second part. Okay. So we use binary search to find it quickly. So the idea, we first find mid in this. Okay. First we find mid. So we do not check every element, we always check the middle element. The middle help as decide left side or right side. So first we must find the middle index. Okay. How we find? If yes, we going to use left and right. Left start from 0 and right start from n-1 nums of size. Left points to the first index and right points to the last index. Okay. You get none this. If nums is equal to 4 5 6 7 1 2 3 and the index are 0 1 2 3 4 5 6. 4 5 6. Just a minute. Okay. Left is equal to 0. Left is here and right is here. Okay. Right is equal to 6. Right is equal to 6. Next what we do? So the formula is mid is equal to left plus right minus left divided by 2. Okay. Right is 6. 6 minus 0 is equal to 6. Now 6 divided by 2 is 3. So the middle element is 3. Okay. Left, add left. Now we add left, middle plus 1, add left will come here. Another example, let's take another example. 4 6 now. If left is equal to left is equal to 4 and right is equal to 6. Right minus left is equal to 6 minus 4 is 2. 2 divided by 2 is 1. So left plus 1 is equal to 4 plus 1 is 5. Just a second. 5. Okay, so the middle element is 5. So we first find how far right is from left, then we take half of the distance. Okay, then we take half of the distance. Finally we add it to left to reach the middle. That's all. So we use binary search. First we compare what nums of mid is greater than nums of right. So this comparison tell us where is the minimum is. If only we have like this 4 5 6 7 1 2 3. Zero, 1 2 3 4 5 6. Okay, so left is here and right is here. Left is equal to 0, right is equal to 6. Let's find the mid. Mid is equal to left plus right minus left divided by 2 is 0 plus 6 minus 0 divided by 2. So the mid is 3. So mid is 7. Okay, now we compare this. 7 is greater than 3. Mid is the left bigger part, minimum is the right side. So what we do, left is equal to mid plus 1 is equal to 4. Mid left comes here. So now we don't want this parts. Okay, and now 4 is, so left is equal to 4 and right is 6. Now it's supposed look like this, 1 2 3. Now let's find the mid. 4 plus 6 minus 4 divided by 2. 4 plus 1 and mid is 5. Mid is this, the index only 4 5 6. So mid is 2. Mid element is 2. So nums of mid is 2 and nums of right is 3. Now we compare 2 is less than is equal to 3. Mid is the right smaller part. Minimum can be mid or left side. Okay, what we do, right is equal to mid is equal to 5. Next new range 4. Now left is equal to 4, right is equal to 5. Now this we cut this part. Okay, we cut this part. Now we have these numbers only 1 and 2 4 and 5 index. Now it's probably look like this 1 2 and the index is 4 5. Let's find the mid. 4 plus 5 minus 4 divided by 2. So the mid is 4. Mid element is 4. So the mid element is 4. Nums of mid is 1. Nums of right is 2. 1 is less than or equal to 2. So what is this? Right is equal to mid 4. Okay, so now we just return nums of left is equal to 1. So the minimum element is 1. This is how we found our minimum element. Let's take another example. Okay, 5 no, let's take this example. Okay, 6 7 1 2 3 4 5 0 1 2 3 4 5 6. So the left here and right comes here. Left is 0, right is 6. Now we found mid. 0 plus 6 minus 0 divided by 2 is 3. Divided by 2 is 3. Nums of mid is 2. Okay, nums of mid is 2. Mid comes here and nums of right is 5. Okay, now we compare. 2 is greater than or equal to 5. Mid is right sorted part, minimum is mid or left. So right of mid is 3. Next range. So this range we cut. Left is equal to 0, right is equal to 3. Right comes here now. So the sub-value of this number is 6 7 1 2. Index of this 1 2 3 4. So let's find the mid. 0 plus 3 minus 0 divided by 2 is 1. So nums of mid is 7 and nums of right is 2. Okay, so nums of mid is 7. Mid element is 7. Now we compare. 7 is greater than 2. Mid is in the left part. Minimum is on the right part. Okay. So what we do? Mid plus 1 is equal to 2. Left is equal to mid plus 1. Now left 2, right comes 3. Now sub is look like this 1 2. The sub is look like this 1 2. Okay. Now we find mid. 2 plus 3 minus 2 divided by 2 is equal to 2. So the nums of mid is 1 and nums of right is 2. 1 is less than or equal to 2. So the right is equal to mid equal to true, right? So the final answer is nums of left is equal to 1. Okay, that's how we find our answer. Let's take one note. No rotation. Okay, 1 2 3 4. 0 1 2 3. Left is equal to 0, right is equal to 3. Okay, let's first we find middle. 0 plus 3 minus 0 divided by 2 is equal to 1. So the middle element is this, left and right. Left and right. So the nums of mid is 2 and nums of right is 4. 2 is less than or equal to 4. So the right is equal to mid minus 1. That comes here. Okay, next find mid. Mid is equal to 0 plus 1 minus 0 divided by 2 is 0. Now nums of mid is 2. Nums of mid is 1 and nums of right is 2. Right comes here. This will be cut and nums of mid is 1. Now we compare. 1 is greater than or equal to 2. Yes, right will come mid equal to 0. So the answer is 1. Okay, so in this, let's write down the code first. And left is equal to 0, start pointer, and right is equal to start size, end pointer. Okay, while L is less than to right. Now we find mid is equal to left plus right minus left divided by 2. If nums of left, no, if nums of mid is greater than nums of right, minimum is on the right side. Now left is equal to mid plus 1 else right is equal to mid. Now we just return nums of left. Return is nums of left. Left pointer is the minimum element. So in this I use binary search. I compare mid and last. If mid is bigger, go to right, otherwise go to left. When left mid slide, then I get the minimum. Okay, so the time complexity is, we go of log n. Why? Because we use binary search. In every step I remove half of the array, and space complexity is, we go of 1. Because we used few variables only, like left, right and mid, we do not use extra space. That's all.